Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 22nd, 2025, about 2 days ago. The big result is a simple loopholing mechanism that carries continuous context through discrete diffusion steps, cutting generative perplexity by up to 61% over prior baselines. The paper is titled Loopholing Discrete Diffusion, Deterministic Bypass of the Sampling Wall, and as we'll see later, the gains are surprisingly broad. In short, this paper narrows or even surpasses autoregressive quality, boosts arithmetic reasoning like countdown and game of 24, and reduces idle steps and oscillations with efficient self-conditioning. Figure 1 shows that loopholing cuts generative perplexity as sampling steps increase. Generative perplexity means lower values signal better text quality. The red LDD-MM curve drops steeply toward the green autoregressive line, while the blue and brown baselines stay high. By 2048 steps, the gap narrows substantially. The labels also note sentence entropy near 5.6, which remains stable across methods. So Figure 2 explains how the method preserves context across denoising steps and trains without heavy unrolling. The left panel depicts standard discrete diffusion, which loses rich information once a one-hot token is sampled. The middle panel adds a deterministic latent path, carrying HS forward so the next step sees both ZT and context. The right panel illustrates self-conditioning, which means a first pass creates a frozen pseudo-context that the second pass uses during training. Alright, Figure 3 shows why discrete diffusion stalls by visualizing the sampling wall and its two failure modes. The sampling wall means the model collapses rich distributions into one-hot tokens, so later steps lose useful uncertainty. One path shows steps without progress, where repeated resampling leaves the sequence unchanged across iterations. Another path shows excessive oscillation, where an unlucky token choice flips predictions back and forth. Loopholing targets both problems by preserving a continuous context through steps. So while Figure 3 showed why progress stalls, Table 1 compares test perplexities to quantify the fix. The table reports that lower perplexity means better language modeling, and the loopholing variants consistently win on both datasets. LDD-MM achieves about 21.90 on open web text, which beats prior masked and uniform diffusion baselines. LDD-MU also improves over its uniform counterpart, showing that the deterministic context path helps regardless of the diffusion noise type. Okay, Figure 5 shows that carrying the latent context longer directly improves quality and stabilizes the trajectory. The left panel reports falling generative perplexity as propagation length grows, which signals better samples. The middle panel shows higher temporal KL early and lower later, where temporal KL means how much the predicted distribution changes between steps, so progress is faster first and steadier after the crossover. The right panel tracks entropy, a measure of uncertainty, dropping more for the loopholing variance, indicating fewer oscillations and greater confidence. Alright, two takeaways stand out. A simple deterministic latent path carries continuous context across diffusion steps, which slashes generative perplexity by as much as 61% and curbs idle steps and oscillations. The broader implication is clear. Non-autoregressive text generation can rival and sometimes beat autoregressive quality at scale. That is it for the AI Research Roundup. I am Alex. Thanks for listening.